How are you guys? Welcome back to my YouTube channel. We're still under Mechanotechnics N5. We've given example 13 read as follow. In the Epicylic gear train shown in figure 1.23, the gear B has that teeth 150 teeth externally. Check, it is externally outside, and 120 internal. See, the gear A has the teeth external. They say the gear external. I want to show you here external. These are gears. It's matching with gear what? Gear A. External, it has the gear. So, and internal gear. The driver A has a 30 teeth, and the arm E is connected to the shaft. You see, is connected to the shaft, right? Then the gear D has 50 teeth. If A revolves at 120 revolves per minute and D revolves at that, we've given the speed of gear A and D, find the speed of arm. And then the arm obviously is connected to what? To the sun key. If we found the speed of the sun key, if we can get the sound or the speed of the sun gear, then is equal to the one of the watt of the arm, because it's connected. They'll have the same speed. Now, if D is now fixed and gear A transmit the torque, we've given that at that, what will be the torque output on the arm E? Okay, it's fine. Let us see how we can attack this question, guys. So the first thing you're supposed to do, always start by these external paths. As you can see here, you must start by the external path with this. Start by the external path. What I'm trying to say there, those gears, they're matching. Gear A matches with this big gear, the annulus, but externally, not internal. Then there's an internal path, but this one also the external path. So if you start by that, you must start by saying, when the gear are matching, we know that you can say TA multiplied by T what? Multiplied by the Tn. We know this formula, TA T multiplied by NP. So let's make NP the subject. Always find the NP first. Then want to make NP the subject, or fine, can divide by TA is B. Sorry, what I've did here. Okay, guys, what I'm trying to say here, I don't know what I'm doing, but I want to say TA multiplied by NA is equals to TP multiplied by NP. We want to make N the subject, NP will be TA multiplied by NA over TP, right? So this is what we have there. Therefore, NP was the key of TA, or we'll call TA this one, the small key there. TA driver A there has 30 teeth. So we have here 30 multiplied by his revolution as 30 keys, what, and A revolves at 120. There's 120 multiplied by 120. then divide by the gear of B, but externally. Remember guys, we're focusing on what? On the external path. External path guys, externally, because this gear A and this and gear A and B, they are matching where? Externally. It's in contact with gear A at external path, there. So the external gear will be what? 150 externally. It's 150. So what will be the gear there? This will be minus 24 res per min. Someone can ask me why I say minus 24 res per min, why I say negative. Is because A will be rotating like that in that direction. We take it that we consider as rotating that side, then B will be rotating at this direction. B will be rotating at that direction. But we are talking about the external part, not the external part. So yeah, that is what we have. Fine. Now we don't know the gear. They've given all the gears, but they did not give us the gear of TC. We don't know TC. We're talking about TC. We don't know the gear of TC. So how can we get that? We'll use our formula, the one for the, we know that we can say TP will be equals to 2 TC. Remember, this is a planetary plus sun key, which is TT, annulus planetary sun key. Use this information. We can make 1 TC. TC, the subject, will have TP minus TT divided by 2. We have 120 minus 1 minus 50 over 2. Take note, B guys will be the internal. Do not use this one, the external path. Use the internal, 120 internal. The annulus again has internal, the internal gear. Now when we are using that formation, we're considering the eternal. Only, I'm telling you guys, the external parts, we'll use it only when you're calculating. When we will use it here only. When you're calculating, we'll use it there only. When we are calculating the number, the speed of gear P only. We cannot use it when we are dealing with the calculation, or on the table we won't use this. We can use it there on the last part, but yeah, I'm talking about the gears, the teeth. We won't use the teeth. So this will have 35 teeth, right? This is what we have there, 35 teeth. This is of what key of TC is the one for the planetary. So we have the gears of the planetary now. So we can use the table now to do our thing. You can formulate the table. Formulate the table. For the first part, I can say conditions. we'll have condition, then say gear P, the planet, the annulus, this is what we have. Then we can say again, gear C, gear D. Then here we'll have the arm. We'll have the arm E. So we have this in the first row. We'll have say there we must now fix the arm E and rotate gear what B, rotate gear P plus 1 revolution. So plus 1 revolution, this is fixed, will be 0 there. So to find TC, obviously we are using this thing, the TC, well, we know that will be TP over TC. That is what we know. TP over TC. Right. Then what do we know? The gear of, remember the gear of TP, the internal part, will focus on the internal now, not the external. The internal gears. What will be the internal? Not this external. Will not focus there. Will focus on the internal. Check there. You must be very careful. We have given there is external. We don't use it. We also use the internal one, which is 120. Yeah. So which is 120 divided by what? 120 divided by the gear of C. Where is C? C, we have calculated it here, 35. So over 35. So this will be equals to what? It will be 3.429. Right. So for gear D, we must know for gear D, if one D will be TP over TC multiplied by TC over TD, but negative like this. You must know that, but mathematically TC and TC will cancel. So you'll be left with TP over TD, negative TD like this. Right. So here we'll simply have minus t tp over, let me just put tp so that we will see, over negative tt, right, because this will be rotating at a anti-clockwise direction. Then this is 120 over minus, what is that? So it was 50, the gear of d, it's 150 there. So here, if you punch this, simplify further, will simply equals to what? Minus 2.4. But this is what we have. So the following table again, here we'll discuss about the speed that we have. So the speeds that we have, so yeah, you can say NP, you can say NT, NE. So yeah, check, we have given you see the speed here, we have calculated it of NP, which is minus 24 here. We have that. So which is the arm, isn't it? We have when then the speed, unfortunately, okay, it's for the p, which is for the annulus, sorry, and p is for the annulus. So for gear p we have the speed there, which is minus 24, we have calculated. Then for NC we don't know, but for gear D, do we know for gear D? The revolution for gear D, let's check there. We have 120, what the torque and stuff there. Okay, D, if we read here, D revolves at date. If you can check the D revolves at date, we've given D, it is date, so we don't know the other. E, we don't know. The speed of the arm, we don't know. Right, this is what we have there, we don't know. So let's go and evaluate. Let's go and find the one of the speed of the arm. We know we'll equate now. we will equate, but we're supposed to multiply by what? By x, and add y. So there's no problem. You see, I was supposed to write it on this column, but it's one and the same thing. It is one and the same thing. As long you will understand what you are doing, we multiply this, the first row, by x, and then we add y, will be, you see, as long you understand what we are doing, will be x1. Then we multiply that value there, we will write it there, will be minus 3.429 x, then you add y. So as you can see, as long you understand what you are doing, minus negative 2.4 multiplied by x and add y, then we multiply that 0 by x, then we add y. X multiplied by 0 would be 0, we add y would be plus y. As long you understand what you are doing, then now we're supposed to equate the speed with this. Just suppose not to cram, do what you know. You add the speed, you equate this, you equate that. So n e is equals to y, we equate just equate your things there, do not. Then here we have minus 24, as you can see, 24 will be equals to that, x plus y, formulate the equation also, 30 will be equals to that, minus 2.4x plus y, 0 will be equal, okay, there is no 0, it's like this. Then the aim we want to calculate this, if we can get the value of y, will be done. So you have 2, 4, then I can make what the subject, I'll make x the subject of the formula like that. Then I will substitute this there. As you can see there, I have what, 30 is equals to negative, 4, then minus four minus y plus y, like this, isn't it? Then here we have 30 multiply this would be positive 57.6, there would be positive 4 point, like y, like this, plus y, then this would be 30 minus 57.6 is equal to, you add this would be 5.4y, divide by that, therefore y will be equals to what? Negative 8,118 we have the value of y now. Then we can take this and substitute there, here. Therefore NE will be equal to minus 8,1 rest per minute. We have this, as you see. How cool is that? But now we have done with this, but I think we are done with that question. Now there's we are done with this one, but now they say if D. Now this is the second. Remember, check here, there's a dot, there's a comma. Now this is a question, it's another question by its own. Now if D now is fixed, now if D is fixed and gear E transmit a torque of 20 Newton at 120 rest per minute, what will the torque output be on the arm E? We want the torque output torque be on the arm E. So you can extend this diagram then. The last part only will only need to extend it. Only need so we'll only need this part. So now in that condition we're given that now NT is fixed, is 0, then they want NE again, but we want the torque, isn't it? We don't know NE. They want to say we don't know NE, but NP, they said they did not change NP, still minus 24. So we still have minus 24 here on the gear B. Gear C we don't know. Gear D now it's fixed, is 0. And E we don't know the output, the arm. Remember, the output is on the arm. That is the output. So if you get found the E, the output speed, then will be fine. Why we're calculating the output speed is because I've shown you this question, this formula, guys. If you still remember it, I've said torque, input torque must be multiplied by input torque, right? You still remember this formula? Then I said plus output torque multiplied by the output torque. Output torque multiplied by this output speed will be plus, remember, torque hold is the torque hold, that one, yes, hold multiplied by the hold speed. Obviously they must correspond. All these must be equals to 0. All of this is equals to, simply equals to 0, all of these things. So we don't know the output speed. The output speed is always at the arm. So if you can find NE, we'll be done with this question. That is our problem there. Then the input shaft, it's at the sun key. The input speed, and the output speed is at the arm. This is at the sun key or at the shaft. So right. So this is what we want to know. So we can. So far, this is what we're supposed to know, but currently let's wait a bit. Let us do what we're supposed to know first. We're supposed to calculate E, as you've seen the output. So you will equate again. This will go with this. X plus y must be equal to minus 24. Equate again. This and that will be what is 0. Minus 0, minus 2.4. X plus y must be equals to 0. We equate y must be equals to E. Y must be equals to NE. So this is what we want actually. So if we can get y, we'll be done solving this question. So we can do our things. Then say can make x the subject will have minus 24 minus y. Then I will substitute this there of minus 24 then distribute there. Will be 5 like this, then will be plus 2.4y. If you distribute again, plus y equals to 0. Take this to the other side, then add this, will be 3.4y equals to minus 57.6 divided by 3.4 both sides. Then y will be negative what? Negative 16.94. Then however, we know that y must be equals to that E. However, we know that NE is equals to y, but y is minus 16.94 grams per minute. So this is an output. Actually, this is an output. It's of the arm. In the arm, we found the output speed there. So we'll use our formula now. Torque in. We'll use our formula. Torque in multiplied by that, and okay. Input torque we've given that was 20. Here it is. Gear A transmit a torque of this 20 at 120. So multiply by 120 plus output torque, we don't know, or do we want, we don't know, we want the output torque. Multiply by the output speed is the one that you've calculated here, It's minus 16,94. Right. So plus torque hold, we don't know, but multiply by, because it's hold, that means you'll have 0. Is hold, there is nothing, there must be 0. Hold, that means fixed, then the speed will be 0. Then this will be, multiply these two, we'll have this, multiply this will be negative 1694, torque out. This multiplied by 0 will simply what? Plus 0 equals to 0. Then here will be minus 940 out. Take this to the other side, will be minus 2400. Then we divide by minus 16,94 both side. Then we'll have S 14.2 Newton per meter. It's output torque. So this is how we calculate this output torque. So thank you for watching, guys. That is an output torque, and you can see this is positive clockwise direction.